Okay, for this lesson, we're going to be talking about gas chromatography. Okay, so how does this work? Now let's just define a few terms first. So the first one is mobile phase and the stationary phase. Okay, so the one that's mobile is the substance that is moving. It's most likely going to be gas or liquid, but it's mostly gas. We can use say gas for the moment. Let's just say it's gas. And the stationary is usually a liquid because that stays still. Stationary means still, so that's usually a liquid. The mobile is usually unreactive, so let's just say helium. Okay, now let's just draw the diagram for the gas chromatography. All right, let's. Okay, so this is mobile, the mobile substance. Okay, so this is the substance that you want to mix with, but it's mixed with a gas, and this is the sample that you want to investigate. It could be injected into the mobile substance, and this is the column. This coiled thing is called the column. This box thing is called the oven. Now the oven, you can adjust the temperature. Okay, so the column, inside the column, you may have the stationary phase. So inside the column is the stationary phase. All right, so why do we use gas chromatography? Well, it is better than paper chromatography, and it's used to investigate complex substances. So it's better than paper chromatography, and it can be used for investigating or analyzing complex mixtures. Right, so what would a graph look like for this? Okay, so for the y-axis, you will have strength. For the x-axis, you have time. Let's just say that's A, B, C, and D. So if you look at A, there's not much of A in that sample. But if you look at D, there's a lot of D in that sample. So the highest concentration is D. Well, how would you say this? The highest amount, the largest amount, or the most amount? The most amount is so the most amount is D. And the least amount is A. I'm being unscientific here. So the one that has the most, the one that's in the sample the most is D, or the highest concentration, you could say, the highest concentration, and the one that has the lowest concentration is A. Which one has the shortest time? So the shortest time will be A, and the longest time will be D. Okay, so the one that has the least concentration is A, the least concentration is E, and the highest concentration is D. The one that stays in there the longest is D, that's the longest time for D, and the one that spins the quickest will be A. Now A, that would mean that A is being carried by the mobile phase. So A, you can say it is attracted to the mobile phase. So A is attracted to the mobile phase, and D is attracted to the most attracted, to the stationary phase. Okay, so A is attracted to the mobile phase because the mobile phase is what's carrying it along. So if it's attracted to the gas, then you'll be joining the gas and you'll come out here very quickly. However, the stationary phase that's in the column, so stationary phase in column. So the stationary phase is in the column. If it's attracted, if D is attracted to the stationary phase, it will stay in that column a longer time. Okay. What can you say about B and C? You can say that B and C have the most equal amount. And just a few more key terminologies that we can talk about. So what is retention time? So retention time is how long it spends in there. So if something has a long retention time, it means it spends there the longest. So the retention time is how long it spends in the column or the whole process. So if something has a long retention time, the time spent in the column is long. Right, because you can control the temperature of the oven, sometimes it could be 50 degrees Celsius to 250. Right, so what happens if you have a high temperature? High temperature, what does that imply? So if you use a high temperature, it usually would mean a short retention time. Okay, so if it's a high temperature, the substance inside will spend there the shortest because it will come out very quickly. It has a high pressure. High temperature would mean high pressure. What happens if it's less soluble? So if the sample does not become a solution or does not dissolve in the solution, what does that imply? It could imply that you will spend longer in the gas phase. So if it's less soluble, then meaning it won't dissolve in the stationary phase, it will spend longer in the gas phase. Now, some molecules could evaporate. So that would mean that if the boiling point is quite... So for example, if the substance has a high boiling point, it would condense. So if the substance, if the stationary phase has a high boiling point, okay, so if stationary phase has a high boiling point, the sample will condense. Okay, so if the stationary phase has a high boiling point, the sample will condense. Yeah. Now there are three things that it could do. There are three things. So the three things are, number one, it could condense in the column. So condense in the stationary phase. That's number one. Number two, what could it do? Number two, now it could dissolve near the surface. So number two, it could dissolve near the surface. Or number three, it could remain as a gas. Okay, so I mean those are the three things, that three main things. So number one, it could condense in the stationary phase. That is if the boiling point of the liquid in the stationary phase is high, then the sample will condense in the phase, or it could dissolve near the surface, or it will just remain as a gas, meaning it won't condense. Okay, and just two more things. So if it's a gas, it will pass very quickly. Yeah, so if it's a gas, it will pass very quickly or quickly pass. Now, if you want to investigate something that's viscous or if it's very sticky, you would use a high temperature. Okay, so high temperature, it could be used to investigate viscous substances. Because it's very sticky, the bonds between the molecules are very strong, so you would need a high temperature to separate those molecules.